Hello everyone, welcome to this series of update webinars on the Oasys LS-DYNA environment software. The 4 webinars detail the recent LS-DYNA updates and the latest features in Oasys 17, which is now available to download from our website. We'd usually provide this information at user meetings we hold in various regions, but due to current circumstances, this is not possible. Although the events have been postponed, we wanted to get these latest updates to you to ensure you know what exciting new features and updates are available to you in the latest versions of the software. The webinar series kicked off on the 6th of May with an update on the LS-DYNA software. Our project manager, Jamie Talbot, also gave us a general update about how we're supporting those of you working from home, the acquisition of LST, and our software team here at Arup. If you didn't manage to catch the webinar, the videos are available on our website, and I'd recommend you watch if you can. So, the remainder of our webinar program looks like this. You may notice a difference with the Oasys themed talks. As the Oasys suite continues to become more integrated, many of the new features and enhancements benefit the whole LS-DYNA workflow rather than the individual products. For this reason, we've moved away from the pre- and post-processing themed demonstrations to how the new features and enhancements aid the whole workflow. So, we're going to kick off with the first of our Oasys talks, Oasys Integrated Solutions. I'd like to start by talking about user interface improvements we've made across the Oasys suite. Based on feedback from our user base, we've been working on improving and refreshing the user interface across the programs in the Oasys suite, and this has now been released with Oasys 17. The Oasys software has developed hugely in functionality, but the look and feel has stayed the same for many years, and we felt it was important to bring the quality of the interface in line with the functionality to ensure the products respond to our customers' needs for market-leading pre- and post-processing software. So for a more comfortable and accessible experience, we've introduced 3 new theme options. We have the light theme seen here, the dark theme, and the classic theme. Now the classic theme uses the same colors that we used in previous releases of our software. We've also improved the font quality. So more fonts are now supported. More font sizes are available to support a wider range of displays, and font quality has been improved as well. Now, the improvements made to the interface ensure consistency going forward, making the software more intuitive to use, easier to learn, and more accessible to non-English speaking users. They also improve the underlying structure of the software to make it easier for us to incrementally develop the user interface and user experience, improve workflows, and add new features and functionality in the future. So the first stage is focused primarily on visual changes to make the interface more consistent and provide a variety of modern color schemes. The interface improvements are easy to navigate and make the software more intuitive to use for current users, reducing the time taken to perform frequent tasks. The changes make the software easier to learn, making training and succession easier across your CA teams. So as there's been no changes to the workflow, no training is required to use the new user interface. Now I'm just going to demo this. So if I open the Oasys shell, so this is the shell that allows you to open our software, gives you links to our manuals, change your preferences, and also to run LS-DYNA. Now, as you can see, this has been refreshed as well. It's now in a horizontal configuration, and the colors have been changed. You can change the themes through the shell, but I'm going to show you how to change the themes through the software. So I'm going to open up Primer. So let me just bring it across onto this screen. So by default, Oasys 17, the programs in Oasys 17 will open in the light theme, as you can see here. As you can see, it looks quite different to how it looked before. Now, also when you open up Oasys 17 for the first time, you will see a splash screen that looks like this. And this gives you some information about the new features in Oasys 17. So the first thing at the top, there's a What's New button. If you click on that, that will open up the what's new documentation that gives you more information about the new features we've added into Primer 17 and D3plot17 and so on. Now also the splash screen will highlight these new themes. So here you can see we have light, dark and classic, and I can click between them through the splash screen here. So if I click on dark, Primer will change to the dark theme, and this is what the dark theme looks like. And if you select the dark theme here, then it will be used for every subsequent session of Primer in this case, because the choice that I've made will be saved into your preferences. We also have the classic theme. So this uses the same colors that we had in previous releases of Oasys. So the idea here is that you can cycle through these themes and choose the one that which suits you best. There's also an option here to turn off anti-aliasing of fonts. In Oasys 17, we've introduced anti-aliasing of fonts, which improves the quality of the fonts that you see on the screen, but some people might want to return to how the fonts looked before, so you can click on plain here to return to that. Now, if you don't want to see this splash screen every time you open up Primer or D3plot or THIS or Reporter, you can click on this button here and it will not show that anymore on startup. So if I close this down, if I now go to display, you can see here at the bottom, GUI theme, this is where you can also change the theme from within the software. So I can change to dark theme again. Here we go. We can look at the dark theme. Or I can change to the classic theme. Now there's also one other option here, and that is the legacy theme. If I click on that, it changes the user interface to the same user interface, button style and colors that we had in previous releases. Now note that we've kept the legacy theme in for Oasys 17, but we plan on removing that in future releases. So I'm going to switch back to the light theme. Now, one thing you'll notice as you move your mouse around in the new themes, that any button that you hover over will be highlighted. This gives you instant visual feedback for where your mouse is, and what's going to happen when you click on those buttons. There's various other changes to certain widgets as well. So you can see here we have radio buttons. These are now rounded and are highlighted when you hover over them. If I read a model in, here we have a vehicle model. If I go to the part tree, expand the part tree, these are the scroll bars that allow you to scroll through lists of entities. As you can see, they have been improved in terms of their visual appearance, but I can also left click through here to make incremental jumps and right click to jump to where I want to be in the list. Now we've also changed the look of sliders. So if I look at this part, for example, and go to the color palette, sliders look like this. So they are now visually different to scroll bars. And you can see how I can click on the central item here, the slider bar, and move it along to change the color. As you can probably see as well, the buttons have been flattened, have rounded corners, which gives a more modern look and feel. Now there are other ways you can change some of the menu attributes here as well. If you go to Options, Menu Attributes, this is a panel where you can change various things related to the menus, and you can change the fonts that are used on the menus here as well. And as I've mentioned, we've added a lot more choice in terms of the fonts that you can choose. As you can see, you've got a lot of font choice now. So you can come in here and change the fonts to whatever you want and save those into your preferences to use in future sessions. Now, finally, I just wanted to show you the change to some of the panels we have here in Primer. So if I open up an edit panel and a keyword edit panel, we have the same buttons at the top of these panels, but they're being made much more consistent across these types of panels. And they're all in the same place. The colors are more consistent. The text written on these buttons is more consistent. And we've also introduced icons as well to make it quicker to understand what the functionality of that button is. So there's been quite a few changes. Please do have a look at them. When you open Oasys 17, this will be presented to you straight away, so you'll see it straight away. And as I said, the splash screen will be there to give you the options to change between the themes straight away to see which one you prefer. So please do try it out and let us know if you have any feedback. So before talking about new features in Oasys 17 for integration of our products, I'd like to just give you a reminder of the existing functionality and how we integrate pre and post processing. So with the Oasys products, you would traditionally look at LS-DYNA input files and output files separately. But it's often desirable to access both sets of information at the same time. So for example, with output results, wanting to look at material properties for a part that has failed. In the input model, wanting to look at spot weld failure of a current analysis when deciding how to change your spot weld configuration. So the ZTF file, which is a file written by PRIMER, allows some model information to be transferred to D3plot to help with this. But the Oasys products now have the ability to open one piece of software from another with the contents linked to allow easy access to both sets of information. So this is functionality we have introduced in the more recent releases of our software. So here we have the Oasys suite products. We have PRIMER for pre-processing your analyses. We have D3plot and THIS for post-processing your analyses. And these can now all be linked together in an interactive way that shares information between the programs. So for example, with PRIMER and D3plot, you can share information such as viewing attributes, cut sections, model data. THIS D3plot, you can share the timeline, for example. And because THIS is such a powerful tool for processing curve information, you can share curve information between PRIMER and THIS. And then we have Reporter that sits between all of our products and allows you to automatically produce reports based on information from PRIMER, D3plot, and THIS. So I just wanted to demo the functionality as it stands in the minute before Oasys 17. So I have here a session of PRIMER open where I have a model that's read in. Now if you go to the top right-hand corner here, you can see there's a post button. If I click on that, I can click on this button that says Start D3plot. So that has detected that for the model I have read into PRIMER, there are some results in the same folder that go alongside that model. And it's opened up D3plot and read that model in. Now if I just move this to my second screen, on the left-hand side here I have D3plot showing the results. On the right-hand side I have PRIMER showing the input model, the keyword file. And these are now in a linked state. And that means I can move the model around in one screen. And the same dynamic movement is mirrored in the other program. Now I can do various other things as well here. I can blank parts. Hopefully you can see I'm blanking parts in one screen and the parts are blanked in the other screen. I can do things like create cut sections. So in PRIMER, if I create a cut section in the model, that is also mirrored into the other program as well. So I'm dragging a cut section in the PRIMER session, but in D3plot you see the same thing. And you can also look at various bits of information as well. There's a link that allows you to share information. So let's say you're looking at your result and you're animating your result in D3plot, as you can see here. I might be looking at a part and wondering why it's performing as it is performing. I can right click and I can click on Edit in D3plot. And in PRIMER, I can directly access the keyword card for that part so I can see what material it is and so on. I might be interested in contacts. So if I right click on the part in D3plot, I can click on the part contact button. That opens up the functionality in PRIMER that allows you to see what contacts that part is involved in. And in very complex large models with lots and lots of contacts, it's often difficult to find that information. So this tool in Primer takes into account all the different ways of setting up contacts, whether you have boxes and so on, excluded part sets, and really tells you what contacts those parts are involved in. It's quite useful when looking at results or maybe looking at instability in your model. And there's various other options in here as well. For example, the part table opens up the part table to give you more information about the part in Primer. So this is just one example of the functionality that currently exists within Oasys 16. Now in Oasys 17, we've expanded on this, and we'll go through that later in the webinar. I'd like to talk to you about a new feature we've added into Oasys 17 that relates to visualization of load profile information and decomposition information. And this is an expansion on features we added into previous versions. So as you may know, Primer can read text files produced by LS-DYNA. You go to check and you click on DYNA output, and you can select the files you want to read information from. Now up until Oasys 17, the information that we read from those files has been limited to errors, warnings, and time step information. And once Primer has read that information, you get a tree view where you can investigate those errors and warnings and look at what might be causing issues in your model. Now in Oasys 17, this has been expanded to read low profile and decomposition information. So when you initialize a model in LS-DYNA, an MPP model, DYNA will write out information to do with how element processing, contact processing, lots of other things is being handled across the CPUs. And also it will write out decomposition information. So this new tool will read that information and display it for you. And that allows you to easily investigate the entities, processes, calculations that lead to your analysis runtime. And it allows you to understand how these processes are spread across CPUs in MPP runs. It will in particular allow you to investigate the effect of contacts in your analysis. And that's important, as contacts can be very expensive for your runtime. And it also allows you to visualize how your model is decomposed across the CPUs. So I'm just going to demo this in Primer. So if I go into Primer, this is a Primer session where I've read in a vehicle model, and I've gone to model check and clicked on the DYNA output file, and that's scanned through all those text files, read information, presented me with this tree view. Now this first tab is what we had before. It allows you to look at errors and warnings. So you can see in this model, we've got 15 warning messages, 15 types of warning message. And for example, we might look at this one here, which relates to nodal rigid bodies, and it's telling me that these nodal rigid bodies, there's a warning message about principal inertia. So I can look at these nodal rigid bodies, I can edit them, I can sketch to see where they are in the model. So it gives you direct access to the entities that are referred to in these error and warning messages, which makes it much easier to investigate these types of problems. But that's been in version 16 and previous versions as well. What we've added is these new tabs across the top, and I'll just go through these tabs and explain what we have. So load profile, what we have here is when LS-DYNA runs, it produces a file called loadprofile.csv, and that contains information on how much time is spent processing certain entities during the analysis. And what we're doing here is Primer is reading that information and presenting it to you in an interactive bar chart. So you can look at this information and try and understand how what's expensive in your model, what's taking up a lot of time, what you might want to change to make your analysis run faster, and how well decomposed your model is and how well spread across the CPUs it is. So what we're looking at here is down the left-hand side, you can see all the CPUs, and this is a 64 CPU analysis. So you can see you've got 64 rows. We can change the size of these rows if you want to expand them to make them bigger, or if you've got more than 64, you can imagine you might want to make them smaller so they fit all on one screen. Now, all the different colors here represent a different entity group or entity type. So you can see here, if we just concentrate on the first row, this orange bar here represents shells, so the processing of shells. And if I hover over it, it's highlighted. And at the top here, it gives you a summary of information related to that bar. So you can see it's shells and the amount of time spent on that shell and the CPU and so on. Green in this case is time step, and then this big blue bar here is contacts. Moving along, orange is rigid bodies, and so on. And you can probably see in this model, you can see the effect of the contacts and how much processing time is going into the contact algorithms within LS-DYNA. Now you can do various things on this chart. You can use dynamic viewing to zoom in and out and pan back and forward. You can look at one particular entity type if you want. So let's say I just want to look at the contacts. I can click on that and you can see how the contact the contacts are spread across all the CPUs. And I can change the order of these. So if I'm interested in seeing what the largest contact CPU is, you can do that. You can see it's in the 7th CPU. We've got quite a lot of contact calculations going on. If you scroll down to the bottom, you can see that goes down to a smaller value. If I now restore the original order, turn everything back on. So this is displaying information in the load profile .csv file. And incidentally, this is the value. So this is an explicit measurement of time, but you can change it to the percentage value as well. You can see what percentage that is over there, the overall time. And there's various other options along the top here as well. Now, as I mentioned, this is reading the load profile .csv file. Now, there's also a contact profile .csv file produced. Now, this is specifically related to contacts, and in this case, it splits up the time taken for all the different contacts in your model. So you can look at this and understand which contacts in your model are the most expensive, which ones are causing the biggest effect on runtime. So you can see all the different contacts that are in the model are across the top here. You can scroll through that list. These are the contact IDs. And you can probably see here from the chart already that this orange one here, I click on it and I can right click, I can click on edit, and that takes me to that contact card. So this is contact 1. This is a global single surface, automatic single surface contact. And if I click on only, you can see here, this is the contact that relates to the barrier in this model. Okay, so this is the single surface contact relating to the barrier. Another one along here, this is contact 2. Again, I can edit this one. And this is barrier to others. So if I click on only, you can probably see that this is the contact between the vehicle and the barrier. And there are others as well, which look like they're reasonably expensive. This dark orange one here, if I look at this one, this is another automatic single surface contact. If I do here, yes, this is the vehicle single surface contact. This is the contact between all the different panels within the vehicle. So as you know, contacts can be expensive. And this is a useful way of understanding which contacts in your model are the most expensive and which are causing problems. Again, if you wanted to look at a particular contact in here, if I scroll down, let's have a look at number 2. I can click on number 2 here and it displays how that is decomposed across all the CPUs. Now the third tab is message profile. Now, this is similar to the load profile tab. But in this case, we're mining information from the message files that are written from LS-DYNA. So message 000 here, all the way down to 63. So there's one message file written for every CPU. And this has similar information to the load profile file, but often gives a little bit more information. So you can see where keyword processing here is this dark blue. MPP, this is the contact algorithm again. This orange one in this case is contact algorithm. This light blue is element processing. So you can see it's similar information but presented in a different way. And you might have reason to look at this file over the other one, for example. If we look at the final tab, which is Decomposition, this allows you to visualize how your model has been decomposed across all the CPUs. Now you need to turn on a particular control card for this, but once that's turned on, LS-DYNA will write out information as to how it's been decomposed on initialization, and then PRIMER will read that file and you can access these buttons here. So at a very basic level, you can click on color elements, and that will change the color of the elements according to how it's decomposed. So you can see the model now is a patchwork showing how the model has been decomposed. Each different color represents a chunk of the model, and that chunk is being processed on one of those CPUs. You can also click on Create Assemblies. Now this creates PRIMER assemblies containing the elements within each of these CPU buckets. And if I show assemblies, see them in the part tree. And that means that I can now say click on Only, and I can start looping through these decomposed buckets and see exactly what elements are within each one. So you can see that one relates to the 14th CPU. So these tools are useful for investigating the load in your model, how things are distributed across the CPUs, and obviously looking at decomposition. Now I've got a similar model here, which has been decomposed in a different way. So this has been decomposed into slices, and this is often more applicable for this particular type of analysis, a front impact. So if I go through the graphs again, here you can see, compared to the previous graph, this looks a lot more balanced. We're doing similar sort of processes across all the CPUs. See, the contacts are very much more even across the CPUs. This is a much more balanced decomposition, which will lead to a faster runtime. Contact profile, again, much more balanced. And again, the message profile, much more balanced. Now I'll just show you, if I go to decomposition, if I color the elements, you'll see how this model has been decomposed to achieve a better balance. So you can see here we've got a series of slices across the Y direction, which gives a much more balanced and decomposed model. So we think these tools are really useful, so please do try them. They expand on the error and warning messages we've read before in previous versions, and hopefully reading the load profile, particularly the contact profile, and being able to interactively visualize the decomposition, how models be decomposed. It will allow you to further investigate errors and problems and issues in your model, which will hopefully be fixed and lead to better quality models and a faster runtime. I'd like to talk to you a little bit about a new way in which you can link together the functionality in our software between D3Plot and PRIMER. So PRIMER has the capability of reading text output files from LS-DYNA. Now that is the message files, log files, D3HSP files. Now those files contain useful information like errors and warnings, and you can use PRIMER to investigate those errors and warnings by sketching the entities that are referred to in those errors and warnings. Now we think it's useful to be able to access that information as well when you're looking at your output results as well as your keyword file. So we've added in a new capability in D3plot to link to PRIMER to access that capability. So when viewing results in D3plot, there's now a direct link to PRIMER to view these errors and warnings. So when you open this new tool, it will open PRIMER in a linked mode so that any entities referred to in those errors and warnings can be interactively investigated in both PRIMER and D3plot. Also note that the stated time at which the error and warning was issued is also stored when reading the output. And this allows you to jump to that state automatically when investigating those entities. So if I just open up D3plot, or D3plot session open here with a model read in, and if I now go to PRIMER in the top right hand corner and click on DYNA output, that will open up PRIMER in a linked mode and automatically read any output files that are identified in the same location as the keyword file and present you with the tree. So I'm just going to share both my screens now. So you can see that PRIMER has opened up on my other screen on the right hand side here, and it's opened up the tree view where you can look at the errors and warnings that exist within the output files from LS-DYNA. And as with anything in our software, when you open it up in a linked mode, if I move a model around in one of the windows, here in PRIMER I'm moving it around, in D3plot, sorry, I'm moving it around, you can see the movement is replicated in the other software, in this case PRIMER. Now if I wanted to investigate some of these errors and warnings, you can see there's a message here related to warpage of some elements. I can sketch or do an only on those elements, and that's again replicated across both windows. So in D3plot and PRIMER, we're just now looking at the elements that relate to that warning message. And obviously in D3plot, I can animate those results and see what effect that these particular entities are having on the model and the results. So that's just a small tool that we've added that allows you to link PRIMER and D3plot together in an intelligent way to access the functionality that exists within PRIMER from D3plot. So I'd like to talk to you about a new way in which we can link together THIS and PRIMER. So when looking at results in THIS, you may wonder why some output options are not available. This is usually because the appropriate output options have not been specified in your input deck. So in your keyword deck, before you run LS-DYNA, those options have not been specified. We've added a new feature to THIS to help you to set the appropriate options to obtain the desired output in PRIMER through a linked session. So I'll just show you this as a demo. I'll just open up a THIS session I have here. And I've got a model read into THIS, and you can see I've got some data, global data and part data, but no other data at the minute. So you might wonder why that you don't have that data. So let's say you're running an occupant analysis. You may be wondering why you don't have seatbelt data or airbag data. So if I right-click on this seatbelt button and click on Edit in PRIMER, that opens up PRIMER in a linked mode. And I'll just share my other screen so you can see this. Here we go. So now you can see both my screens. And on my right-hand screen, PRIMER has opened up in a linked mode with the THIS session. So it knows the keyword file that it needs to read in. And it's opened up the database ASCII cards, and it's highlighted the field, the card that you want to activate and specify to obtain seatbelt data. So you can see SPT out is specified. Now, what about airbag data? If I right click here, edit in PRIMER, here, hopefully you can see on the right-hand side, it's highlighted abstat. Now, in case you can't see this, I'll just zoom in on the right-hand side. So you can see that. So here, abstract has been highlighted and SBT out has been highlighted as well. Now, if I go back into THIS, for shell, let's say you want to obtain some shell output data. If I right-click there, edit in Primer, let's have a closer look at the right-hand screen here. You'll see that we've opened up the database binary card, where it's highlighting the D3THDT file, which you have activated here already in this model. But it also highlights LOut in the database ASCII cards, and also brings up the database history shell card, so you can specify shells you want output for. So hopefully, this makes it easier when looking at your results to identify issues that you have in your model that you may want to rectify to achieve the output results that you're looking for.
Hello, it's Alistair here, and in this part of the webinar, I'll be telling you about how you can add Reporter to your LS-DYNA workflow. We've made some big changes to Reporter in version 17, so I'm really excited to be finally sharing them with you. But first of all, a very quick introduction. Reporter is a powerful tool for automating the post-processing of your LS-DYNA models. It links with Primer, D3plot, and THIS to extract images, graphs, and other key results data. You can set up Reporter to run in batch from the command line after each of your LS-DYNA jobs, or you can configure it to run in batch from shell. You can use Reporter templates as a container for your JavaScript and FastTCF scripts to manage all of your automation tasks in one place. And the reports can be exported to PowerPoint, PDF, or HTML for sharing with your team. So what's changed in version 17? Well, we have overhauled Reporter to give it a new integrated workflow. What does this mean? Well, let's start with the old workflow that existing users would be familiar with. After setting up my models in Primer and running the LS-DYNA solver, I would be looking at results in D3plot and THIS. At this point, I might decide to create a report, either to share the results directly with my team, or to set up some automated reporting for future analysis runs. So what do I have to do next? Well, in the old Reporter workflow, I would have to launch Reporter separately. For a new project, I would typically start with a new empty template, and I always find it harder to start anything from a blank sheet of paper. I could add D3plot items and THIS items to the template, but each time I have to launch a new session to capture the images and graphs. These sessions aren't linked to my original D3plot THIS session, so I have to open the models all over again and get back to where I was. We wanted to improve all of this to make Reporter easier to get started with and quicker to use. So, in the new Reporter workflow for version 17, we start as before, set up the models in Primer, run the LS-DYNA job, and look at the results in D3plot and THIS. But now, you can open Reporter directly from D3plot and THIS in a linked session. In version 17, when you start Reporter, you can open your recent reports from a list or choose a template from a range of standard layouts. This makes Reporter easier to get started with, and the linked session gives you a more seamless workflow. After choosing a template, you can capture images and graphs directly from D3plot and THIS into your report. With version 17, you can start automating your reporting right away. To show you how all of this works in a bit more detail, I'm going to give you a bit of a demo. In this webinar, I'll focus on the new integrated workflow. But as we go, you'll notice that there are lots of other new features in Reporter 17. We'll look at those in more depth in the next webinar in the series, which covers all of the new features to accelerate your workflow in the Oasys LS-DYNA environment. In this demo, I'll show you how to add Reporter to your LS-DYNA post-processing workflow. Here I have a linked D3plot session where I'm looking at some analysis results. Now, obviously, we could be looking at anything here, but for the purposes of this demo, in the top left, I have a pedestrian head impact simulation, currently showing a contour plot of the inner bonnet displacement. On the right, I have a graph plotting the filtered head impact or acceleration over time, showing the standardized head injury criterion, or HIC value. And in the bottom left, I also have a completely different model. This one is an offset deformable barrier simulation. So when I want to start reporting, I can now click the Reporter button in the top right of the main toolbar. This opens Reporter as a linked session. So it's now linked to the D3plot session that we started with. When I start Reporter 17, I can open my recent files from the list on the left, or I can choose one of the library templates on the right, which include a set of standard layouts to make it easier to get started with Reporter. We'll be covering more of the features of this panel in the next webinar in the series, but for now I'm going to filter by title page and then pick one of the themes. Here I'm going to pick the executive theme in widescreen, and the title page opens. The next thing I'd probably do is add a page with one of the standard layouts so that I can start adding content from D3plot and THIS. I'm going to pick this layout with 2 placeholder items on the page. Placeholder items are new for Reporter 17, and they're designed to be replaced with content from either D3plot or THIS. So if we look back at D3plot, we can see that when we launched Reporter, it opened the Reporter panel in D3plot, and it's showing the item tree, which lists all of the templates, pages, and items that are currently open in Reporter. If we select one of the items on the item tree, then the corresponding item is selected in Reporter. Likewise, if I select one of the items in Reporter, then it updates the selection in the item tree. We can use this to select items on different pages. So if I select an item on the item tree in page 1, then it will switch the view in Reporter to show page 1. Likewise, if I change page in Reporter, then the selection is updated in the item tree. When I'm ready to start capturing content from D3plot and THIS, I can use the Reporter panel to capture whatever is the active window. So if I select window 1 and press the capture button, then the D3plot content from window 1 appears as a new D3plot item in Reporter. And that's because when no items are currently selected in Reporter, the default action in the item tree is to add a new item on the current page. But I wanted to make use of the standard layouts we have in the Reporter template. So I'm going to delete this item and capture again. But this time I'm going to select the placeholder item from the item tree on page 2 and then press capture. This time the D3plot item takes the position of the placeholder in Reporter. As well as capturing content using the item tree and the Reporter panel, we can capture content from the windows and graphs directly. You'll see that when Reporter is linked to D3plot and THIS, then each window and graph has some additional buttons. So this time I'm going to select the second placeholder item in Reporter and then go back to the THIS graph. First, I'll click Resize to resize the graph window to match the aspect ratio of the placeholder item in Reporter. And then I'll click the Capture button on the graph to capture the THIS graph into Reporter. If we go to Presentation View, then we can see that the THIS graph has been resized to match the layout, but our D3plot item was captured using the aspect ratio of the window in D3plot. If we want to make our D3plot item match the layout, then I can go back to Design View, open up the D3plot item, and look at the image properties. We can see that D3plot has given the item a custom aspect ratio matching the dimensions of the window in D3plot. If I change this back to Fit Object Box, then when I go back to D3plot, I can resize the window to match the reporter item and hit capture again. And now if we go back to presentation mode in reporter, we can confirm that the layout has been updated. Now you might have noticed that the resolution of this image currently isn't very good, and that's because when we're capturing items, D3plot captures the image at the resolution of the window on your screen. But don't worry, when you generate your template, D3plot and THIS will generate each item on a new page to maximize your image resolution. I can demonstrate that by selecting and generating the item from Reporter. You'll see that D3plot has generated the item in a new page, and so now the image resolution looks much better. So now you've seen how to capture and generate items using the new integrated Reporter workflow. But in this example, the model has been hardwired into the template. And the main benefit of Reporter is to be able to set up one template to run on all of your analysis simulations as your project evolves. So I'm going to quickly run through the example again, but this time we're going to make use of Reporter variables to set up our template to run on a real project. So I'm going to close down Reporter and we're going to start back in our D3plot THIS session at the point when we decided that we wanted to create a report. I'll start Reporter again, and we'll filter by title page, select the executive theme, and add the page with the two placeholder items. Now this time I'm going to go to the variables menu and click edit and change the values of the default directory and default job so that we can change them when we run the template in future. I could browse for a directory here, but I'm just going to paste in the directory of the model we've been using. And because I'm using the Oasys file name convention, then I'm going to select the PTF file. If you're using the LSTC file name convention, that file is usually called D3plot. So once I've set the default directory and default job, I can continue as before. So we'll select the first placeholder item in Reporter, and then in the D3plot window, we'll click Resize and then Capture. And then we'll select the second placeholder item in Reporter. And then for the THIS graph, we'll click Resize. But this time, before we click Capture, I'm going to use another feature of Reporter variables and extract the HIC value from THIS and use it in the caption in my Reporter template. To do this, I'm going to go to the Reporter panel and click Show Variables. If I make sure that the active window is the graph, then I can start adding variables to my THIS item. Now, THIS has already suggested two new variables, which are the minimum and maximum y value over all of the curves in the graph. But actually what we're interested in is the HIC value. So I'm going to add a new variable, change from all curves to the acceleration curve, and then under property, select HIC. I'm now ready to capture the THIS item into Reporter, so I'll click the Capture button. Now in Reporter, I can go to the caption and write HIC value, and then right-click to insert the variable that's been added from THIS. So I can see the HIC value here, and I'm going to set it to a floating point number with 1 decimal place for display. If we go to presentation view, we can see that the variable value has come through to Reporter. So now our template's pretty much ready to go. I'm just going to check that our D3plot item isn't using a hardwired model name anymore. Now, because the model that we captured from D3plot matched the default DIR and default job variables that we set, then it's automatically used the variables in the file name. If you find that your model is still hardwired, you can always change it to match the variables so that you can use the template on more than one analysis simulation. I can double check that the same thing has happened in THIS as well, and our template is ready to be saved. I'll call this template head impact, click save, and there we are. We've now used the new Reporter workflow to create a template for our project. The final step to adding Reporter to your workflow is to set up Reporter to run in batch automatically at the end of your LS-DYNA jobs. If you have an existing command line process for LS-DYNA job submission, then you can add an extra command line to run Reporter, like this example here. There's more information on the command line options in the reporter manual. Alternatively, if you submit your LS-DYNA jobs using shell, then you can select the option to run reporter after analysis. Just make sure that the display is pointing to a valid display on your server that reporter D3plot and THIS can use to generate graphics. Click the Options button to choose the input files, the templates, and the output options for your reporter process. If you've already run your LS-DYNA jobs, and even if you don't use shell for job submission, then you can access the same options panel from the Batch button under Reporter. Here, the input file is the keyword file or the results file for your job, it doesn't matter which, and because I set up my pedestrian head impact analysis using Primer's pedestrian markup tool, then I can use the list file it generated to populate the inputs. Now, I don't want to run all of them now, so I'm just going to select a couple, and then under Template, I'm going to select the template we saved. The output directories and the file names for our reports are pre-populated, and by default, it's going to output in Reporter, PDF, and PowerPoint format. I can also set various options here to control the process. When I'm ready, I just click Run Reporter, and the batch process begins. For each of the input file names we selected in the list, Shell updates the values of the default dir and default job variables and generates the template. While it's running, I'll just mention a couple of other things about the new reporter workflow. For now, Primer items continue to work in the same way that they did in Reporter 16, and any of your older reporter templates will continue to work in Reporter 17. Now that the batch process is finished for the two models I selected, I can open up the reports in Reporter, PDF, and PowerPoint and share them with my team. And I hope that the new workflow for version 17 makes it easier for you to use Reporter on your projects.
To wrap up, I just wanted to let you know about the new features information available on the website. These PDFs provide more information on the new features in each of the individual programs in the Oasys suite. They can be found in the Oasys suite downloads area under documentation. I hope you found that useful and interesting. If anyone has any questions on the material presented or anything related to the Oasys software, Alistair and I are online now, and you can contact us through the question box. You can, of course, contact us at any time through your usual support channels. Please don't forget to join the other Oasys webinars over the next 2 weeks. We look forward to seeing you dialed in. Thank you.